Hello everyone, welcome back to NEET World. So this is our day 2 of EAPCET 2026 preparation, right? So now here I have came up with the important topics. Especially today we will be focusing on very basics of chemistry. Now I will show few questions that are asked in EAPCET which we can able to solve without knowing in even a simple single concept also. For example, I will show you a few questions. Look at here. If you know simple mathematics or the simple formulas, see here you can able to solve this kind of question. See, this is asked in 2023. Look at the question. The weight percentage of carbon and hydrogen in hydrocarbon is in the ratio of 4:1. Then what is the empirical formula? See, just by knowing the very basic things like what do we mean by empirical formula and molecular formula and understanding the word hydrocarbon. It means hydrocarbon means definitely should contain carbon and hydrogen. Now, how the ratio of this carbon and hydrogen given here, that must be 4:1. Now look at the option, we have 4 options. In which option we have 4:1 mass ratio for carbon and hydrogen, that's it. See, even without knowing any like detailed concepts also you can able to solve this kind of question. Okay, I will help you from very basic. This is the question I have collected just because to give you some confidence that you can able to solve the questions even having very low knowledge also on the concept. What is my intention here? To make you feel confident over the problem solving first. Approach the question whatever the knowledge you have. Okay, even if you are preparing for IP, just solve this kind of question, then you can boost your confidence from that. So look at here, 4:1 is a empirical formula mass ratio, they are like formula ratio, mass ratio they are saying. Now we know for carbon atomic mass is 12 and for hydrogen it is 1. So if it is simple CH, it must be 12:1. But they are saying 4:1. Now take the second option here. So 12:2, 2 hydrogens are there. So each hydrogen is mass 1, 2 hydrogens are there, 2 into 1. So this will become 6:1 ratio. But we want 4:1 ratio. Now look at here, carbon 12, hydrogen 3 hydrogens are there. Each hydrogen is having atomic mass 1 right now. So therefore the mass ratio will be 4:1. It means what is our option here? Option 3 will be perfect answer for this particular question. Hope this is clear and it is very simple right now. Now tell me what is the mass ratio for methane here? CH4 is given now. So for carbon you can take it as 12 and for hydrogen we have 4 hydrogens, each one mass is 1. So 4:12 means I can say 3:1. Right? So 3:1 is a mass ratio for carbon and hydrogen in methane. And in the question they are asking 4:1, it means option 3 will be very suitable answer. Hope this is clear. Let's begin our session with very basics first. Okay, and I will also show you some other questions. See, this is also very basic. Look at this. In the balanced equation, the following reaction, in the balanced equation of the following reaction, the ratio of A by B is A. What is the option they are asking? This is also very simple. See, you don't need to know the concept involved in the reaction also. Just look at these elements. Here we have calcium carbonate. So whatever the elements present in this LHS side, same number of elements should be there at RHS side. Okay, it means during a chemical reaction, the total number of atoms, the total atoms of a particular element must be conserved. Okay, LHS should be equals to RHS. This is a basic fundamental concept you can use here. See, just look at here how many calciums are there here. We have 1. Just ignore this A, B, C. This coefficients you ignore. Now look at the equation. Product side we have 3 calciums. It means reactant side also we require 3 now. So multiply this with 3. Therefore we will get 3Ca. Therefore we will get 3CaCO3. We will get 3CaCO3. And then next, how many phosphates are there here? PO4 ions are 2. So it means this reactant side must be 2 orthophosphoric acid should be there. Hope this is also clear. Right. Now after this, what they are asking A by B ratio. By using this only we can directly answer this is 3/2 definitely. Or if you want you can balance complete equation also. Definitely P will be 1 because 3 calcium means 3 into 1 means 3. Okay, and the next phosphates 2 into 1 means 2. That's it. Next, how many carbons are there reactant side? 3 carbons are there. So it will give 3 CO2 gas. And the next, how many hydrogens are there this side? We have 2 3 is 6. Here 2 are there means you just take here 3. That's it. So what are the stoichiometric coefficients here we got? A is 3, B is 2, and next here P is 1 and Q is 3 and R is 3. That's it. This will be the thing we need to do here. Right? Now look at the question they are asking A by B. It means A by B means 3 by 2 will be our answer, which is option number 2. Right? This is also simple now. Without knowing the concept involved in the reaction, we can able to tackle this kind of questions. So be confident, whatever the concept you have studied till now, use that concept and start solving the questions. Okay, from each chapter you can do in the same way. Okay, so as of now, this is the day 2. I am beginning these sessions with very basics like mole concept first. After that I will be looking into periodic table, and after that structure of atom and chemical bonding, like that. Okay, so now look at few more questions based on this explanation. Now try to solve this question. The number of moles of hydrogen which is required to produce 10 moles of ammonia in the following reaction. Just give a try. I am expecting answer in the chat box from someone. Yeah, look at this. The number of moles of hydrogen which is required to produce 10 moles of ammonia. So how many moles of ammonia required? As per the question, 10 moles of ammonia is required. So now we need to balance the equation that contains 10 moles of ammonia in the product side. Okay, so try to balance the equation, and whatever the stoichiometries we will get, those are our answers here. Okay, NO2 and H2. Okay, so in order to get this 10 ammonia molecules, we definitely require 10 nitrogen atoms. Definitely this will be 10 NO2 then, right? And in order to get this 10 ammonia molecules, hydrogens are how many for one molecule? 3. So 3 10s are 30. So there will be 30 hydrogen atoms as of this. Okay, let us consider 30 means I can write 30 hydrogen atoms here. And now next, what about this oxygen atoms here liberated? So out of this 10 NO2, how many oxygens are there? So 2 10s are 20. So here it should be 20, right? So now total number of hydrogen atoms from here it is 30, and from here it is how many? 20. From here it is 40. So total 70 hydrogen atoms are there. So if we have 70 hydrogen atom, reactant side you can take 70 by 2 H2. 70 by 2 H2 because here H2 molecule, in one molecule there are 2 hydrogen atoms. So it means 70 by 2 into 2. That is nothing but 70 by 2 into 10. It means just you can take here just 35. So that is what the answer here will be, because they are asking what is our A here. So simply you can take 70 by 2, that is nothing but 35. Therefore it will give 70 hydrogens. See, 35 into 2, that will be our 70 will be the total number of hydrogens must present in the reactant side. As product side are 70 hydrogens. Is this clear or not? Hope this is clear, right? If any confusions are there, please let me know in the chat box. Yes, and if you are new to this channel, click on the subscribe button so that you will get daily updates from our side. Just now we have finished our physics class also for EAPCET in this same channel, in the same manner like live session itself, and followed by we will be having zoology, botany, and for mathematics students, for MPC students, mathematics class will be there every day. Okay, right? And you can also share with your friends who are preparing for EAPCET 2026 and upcoming JEE and NEET exams also. Okay, right? Let's go to the one more question similar to this. Here here when it comes to chemistry, we will be using some specific terminologies here. See, when we go to a market, we are calling it as like 1 dozen of apples or 1 dozen of eggs we are calling, right now, half dozen eggs. Instead of saying 12 eggs, we will be saying dozen eggs, like that, right now. So similar to this term, we have a term called mole. So this mole represents Avogadro number of particles. So what is this Avogadro number? Similar to whenever we say dozen, you are saying 12 now. So similar to when I say mole, this is equivalent to 6.022 into 10 power 23 atoms. Okay, if I say 1 dozen atoms, that will be 12 atoms, right now. If I say 1 mole atoms, that will be equals to this much bigger number, 6.022 into 10 power 23. Okay, so now, so why do we need to represent this number? Because even if you take small quantity of any chemical substance, it will contain n number of, like large number of atoms, right? Large number of minute particles are there, because atom is very, very small particles. Therefore, if you take any matter or any chemical substance that is made up of large number of atoms, in order to indicate that large number of matter, in order to deal with that many number of atoms, we are simplifying that bigger number of atoms, that many number of atoms, to a simple quantity called mole. That's it. Okay, so now 1 mole of a substance, if I say any chemical compound, contains 6.022 into 10 power 23 atoms I am saying, 23 particles I am saying. So now this will be equals to its molar mass. What I am saying? Molar mass. So for example, CO2 we have, CO2 gas I am taking. So what is the molar mass of this substance if someone asks you? Just look at here. Carbon atomic number is 6 na, so double its mass. Now like mass number will be double of its atomic number, you can consider like that, because an atom contains, like carbon atom contains same number of protons, same number of neutrons here, 6 protons plus 6 neutrons, therefore its mass become 12. Similarly, oxygen atoms are 2 here, each oxygen atomic number is 8 we know, therefore its mass number becomes 16, 16 into 2. Therefore, it will be how much? 32 plus 12, 44 grams. This will be the molar mass of CO2 gas, I can say. Now, this 44 grams of CO2 gas will contain 1 mole CO2 particles. 1 mole CO2 particles, or we can say Avogadro number of CO2 particles, 6.022 into 10 power 23 CO2 molecules will be there. Okay, so for example, if I am giving you 44 grams of carbon dioxide and I am asking how many carbon dioxide molecules will be present in that, it contains this many number of, like Avogadro number 6.022 into 10 power 23 CO2 gas molecules will be present. Okay, yes, this is experimentally observed data also. Okay, so you need to remember these specific terms here. Okay, because these are the basic terms which we will be using throughout the chemistry part. Okay, now sir, if I am giving you 44 grams, you are saying it as Avogadro number, this many number of gas molecules are there, CO2 molecules are there. Sir, if I only give 22 grams, now what happens? See, mass become half now. Mass become half, therefore number of particles also become half. It means 6.023 into 10 power 23 by 2. It means 3.011 into 10 power 23 CO2 particles will be there, CO2 molecules will be there in 22 grams. So this is the way you can able to understand the concept. Hope this is clear. Now look at our question. 1 mole of gas, 1 mole of oxygen gas at STP is equals to, so 1 mole of any substance, what I told you, at STP or any condition, 1 mole of a gas, 1 mole of a gas contains Avogadro number of particles I told now. So what is that Avogadro number? 6.022 into 10 power 23. So they are saying oxygen gas. Oxygen gas exists in O2 form now. So you can say O2 form means molecules, oxygen molecules. So 1 mole of oxygen molecules is nothing but 6.022 into 10 power 23 oxygen molecules, molecules of oxygen. If they say atoms, the answer will become different here. Why it will be different? In 1 molecule of oxygen, there will be 2 atoms now. Therefore, the number of oxygen atoms here will be Avogadro number 6.022 into 10 power 23 into number of atoms here in one molecule. 2 are there, so 2. So this number is there now, this 2 is a number we are saying now, that is called atomicity of that particular molecule. What is the atomicity of oxygen here? 2. Similarly, if I say N2, nitrogen, I am saying what is the atomicity of nitrogen? 2. So we need to multiply with that atomicity in order to get number of atoms in particular moles of substance. So 1 mole of oxygen gas at STP contains Avogadro number of oxygen molecules or 2 into Avogadro number of oxygen atoms. Hope this is clear, right? If these are clear, please click on the like button. Now for this particular question, our answer should be first option. And now from now onwards, this Avogadro number 6.022 into 10 power 23 is there now. I am indicating with a symbol Na. So Na is a symbol used to indicate number of particles, like Avogadro number of particles. Okay, right. So now tell me, in 1 mole of oxygen gas at STP contains how many oxygen atoms? You can simply say it as Na by 2, because Na number of oxygen molecules are present. So atoms means, sorry, Na into 2. Na into 2 number of oxygen atoms will be present, like 6.022 into 10 power 23 into 2. So in this way, I hope it is clear. Now instead of giving like this, I am giving you what is the weight of 3.011 into 10 power 23 oxygen gas molecules. Now can we answer this one also? Yes. See, we know if it is 6.022 into 10 power 23 O2 molecules, we are saying its mass number will be equals to 32 grams. Right now, because O2 means 2 into 16, so 32. Okay, but given quantity is 3.011 into 10 power 23. So it means number of atoms become half, means its weight also becomes half now. So this will be corresponds to 16 grams. Hope this is also clear, right? Now can you answer this question? Look at this. What is the total number of electrons present in 1 mole of ethane? See, 1 mole of ethane means, what is the formula of ethane? C2H6, right now? So 1 mole of ethane means 1 mole of ethane contains Avogadro number of ethane molecules. Okay, this Avogadro number multiplied with, in one ethane molecule, how many electrons are present? See, total number of electrons they are asking now. So in one ethane molecule, how many electrons are present? What is the total number of electrons present in 1 mole of ethane? See, there are 6 carbon atoms. So each carbon atom contains 6 electrons, right? Sorry, 2 carbon atoms. C2H6 now. So 2 carbon atoms, each carbon atom contains 6 electrons because its atomic number is 6 now. So number of electrons and number of protons are equals to its atomic number, right? And 6 hydrogens are there, each hydrogen atom contain 1 electron. Therefore Avogadro number multiplied with 12 plus 6. So we can say 18 into this Avogadro number. What is the Avogadro number we have? 6.022 into 10 power 23. So simply we can say this as 16 into 6 into 18. So 8, 4, 108 into 10 power 23. This will be our answer. So weight do we have? See here, 108.4 into 10 power 23. So option C will be very suitable answer. See, I am giving you the concept just by using PYQs only. Okay, so now what we need to know? We need to learn some concept again some more detailed concept, and then we'll come back to the numericals once again. Okay, so just boost your confidence. Till now I have taken very basic numericals from EAPCET 2023, 2024, 2020 to give you some clarity over numericals. Now I will be giving you the concept first, theory knowledge first, then later on we'll solve the questions. Okay, so every day I will be discussing some theory part and solving numericals related to that from EAPCET, JEE or NEET exams. Okay, since these sessions are exclusively for EAPCET, we'll focus more on EAPCET. Okay, and if there are some mixed students, we'll try to cover some important PYQs of NEET and JEE also here. Okay, right. So once again, what do we mean by 1 mole? 1 mole is a quantity of substance that contains Avogadro number of particles. For example, in terms of carbon, if I talk, see, a mole is defined as the amount of substance that contains as many particles as there in the exactly 12 grams of C12 carbon. Okay, now 12 grams of C12 carbon if I take, it contains Avogadro number of particles. This is based on practical observation, that is 6.022 into 10 power 23 number of carbon atoms. Okay, right. So based on this we are defining 1 mole as the number of particles that present in 12 grams of C12 carbon will be considered as 1 mole. Okay, so similarly, now I told you that mole is nothing but a term used to define number of chemical particles like entities in a given amount of substance. That is like dozen X, we are saying 12X. Similar way we have a mole concept here. Okay, so now one more term, molar mass. What do we mean by molar mass? See, this is the mass of a substance of 1 mole of mass of a substance for 1 mole of quantity. If I take 1 mole of any quantity and if I measure its weight, that weight is considered as molar mass. See, the mass of 1 mole of entities expressed in grams is nothing but its molar mass. So what is the unit for molar mass? See, mole or mass, like gram per mole. The quantity, the weight of a substance per mole is considered as its molar mass. That's it. Okay. Now it is also called as gram atomic mass. In some questions it will be mentioned gram atomic mass. Don't worry about that. Or gram molecular mass for molecules. Okay, remember these terms. Next, now how can we calculate this number of moles? Okay, let me give you some basic formulas here. So number of moles can be calculated, number of moles. So we know 1 mole of a substance, 1 mole of a substance weight is considered as its molar mass. Okay, so I am giving you some X grams of weight, then I am asking you number of moles. Then what we will be doing? So given weight, so simply you can use this unitary method, number of moles I am asking, which is N. So that N into molar mass, which is equals to X grams by X grams into mole divided by this N. So it's N equals to given weight, that is X in grams, by its molar mass. What is the units for molar mass? I told you gram per mole. So simply what is the formula we got finally? You take given weight of the substance by its molar mass, which is gram per mole, which is unit of molar mass. Okay, so from this gram can be cancelled. So what is the units for number of moles? It's just moles only. What is the unit? Mole only. Okay, right. Now for example, I am giving you 24 grams of C12 carbon, express number of moles of C12 carbon. So what to do? So 24 grams now, given weight is 24 grams. So take 24 grams, and what is the molar mass of this carbon C12? That is 12 grams per mole. Okay, so we will get 2 moles. So we can say 24 grams of C12 is nothing but 2 moles of C12 carbon. That's it. Right? Next, if I am giving you 48 grams of methane, then express number of moles of methane if I ask. What will be your answer here? Say given weight is 48 and its molar mass, how much? 12 for carbon plus 4 hydrogens are there, 4 into 1. So this will be 16. So it will be how much? 3 moles. Right now, so number of moles of methane here we can consider as 3 moles. Hope this is also clear. Right. Now let me tell you a few more examples. Basic formula I have given is given weight of that substance by its molar mass I am saying. Now in the same way, instead of asking number of moles of methane, what if I ask number of moles of carbon? In the simple way I will tell you how to do this. In 1 mole of methane, in 1 mole CH4, see in 1 mole CH4 how many carbons are there? 1 mole of carbons will be there. Similarly, what is the answer we got here? 3 moles of methane, therefore 3 moles of carbon atoms will be there, carbon atoms will be there. Similarly, if I ask how many moles of hydrogen atoms, see in 1 mole of methane we have 4 hydrogen atoms, 4 hydrogen atoms. In 1 mole of methane we have 4 moles of hydrogen atoms. Similarly, we got our answer as 3 moles of methane now, so 3CH4. It means how many moles of hydrogen atoms will be there? So 3 multiplied with 4, so 3 4s are 12, so 12 moles of hydrogen atoms will be there in this methane of 3 moles. Hope this is clear, all the things. So this number which we are using here, this 4 and for carbon 1, those are called atomicity of that particular element in the given compound, right? Yes. Hope the things which we are discussing here are clear, and if you have any concerns, you just tell me in the chat box. Everything is clear now? Right. Let's move forward with few more examples. Look at this question. Which of the following represents 180 grams of water correctly? See, 180 grams of water correctly means, look at here, first option they given 5 moles, 10 moles in the second option. So just we need to first find number of moles of water first. Number of moles of water is nothing but given weight is 180 grams, so given weight 180 by its molar mass. What is the molar mass of water? So H2O, right? So for oxygen 16, hydrogen 2 into 1, so total 18. So take 18 gram per mole. So that will be 10 moles. How many moles of water we have? 10 moles. Okay. So it means option 2 will be perfectly correct now. Okay. And if I want to check other options also, whether this second option, third and fourth options are correct or not. See, we know 1 mole contains Avogadro number of particles, water molecules. We got our answer as 10 moles. It means Avogadro number multiplied with 10. This many number of water molecules should be there. So that is nothing but 6.022 into 10 power 24. So it means option 2, option 4, both are correct only here. Right now, hope this is also clear. Right. So now one more formula here you can remember. First formula I given, finding number of moles using given weight by its molar mass. Second formula is 1 mole contains Avogadro number of particles we know, right now. So now they will give some particles number and they will ask number of particles or number of moles. So number of moles giving some X particles. So what we can do, number of moles equals to number of particles given, this is X, number of particles given. This method is called a unitary method, like getting the formula here. Number of particles given, that is X, by its Avogadro number. So this is the second formula that you need to remember here. Okay, so that you will get this fourth option using this formula. Okay, understand the concept. From that you can make the formulas. First understand the concept like this and make the formulas from that. Okay, right. Next here we have look at this question. Number of oxygen atoms in 4.4 grams of CO2 gas. So tell me, how can we do this? Number of oxygen atoms in CO2. Simple. First of all, find number of moles of carbon dioxide. Given weight is 4.4 and its molar mass is 44. You will get 0.1 gram, 0.1 moles of CO2 will be there. Okay, so in 1 mole of CO2, we have in 1 mole of CO2, see how many oxygens are there? 2 oxygen atoms are there. In 1 mole of CO2, we will be having 2 moles of oxygen atoms right now, because 1 molecule contains 2 oxygen atoms. Okay, so when we have 0.1, so what will be your answer? It will be contains 2 into 0.1. It means 0.2 moles of oxygen atoms will be there, right? So 0.2 into 6.022 into 10 power 23. Why we are multiplying with this number? Because 1 mole is nothing but Avogadro number only, no? That's why 0.2 into mole means 0.2 into Avogadro number, right? So from these you can write 12.044 into 10 power 22. Okay, so just check, do we have any option like this? Or we can write 1.2 into 10 power 23. Yes, we have an option in this way, like first option 1.2 into 10 power 23. So our answer will be here. Our answer here will be first option. Hope this is also clear, right? Let's move forward with few more questions. Number of which of the following contains atoms equal to those in 12 grams magnesium? So 12 grams magnesium, it means number of moles you find first. Number of moles of magnesium is equals to given weight 12 by its molar mass is 24. That is 1/2 mole. Okay, 1/2 mole of magnesium is present, right? Now in this first option you take number of moles of carbon will be equals to given 12 grams and its molar mass also 12 gram per mole. It means it will be 1 mole. But how much we require? Half mole of substance is required, because they are asking which of the following contains same number of atoms as those in 12 grams of magnesium. So 12 grams of magnesium contains half magnesium, half mole of magnesium, that is half into Na. Number of magnesium atoms are present. Okay, this is contain 1 mole, that is Na number, so it is not the correct. Next, go to this option. So number of moles of nitrogens will be taken as given weight by its molar mass multiplied with atomicity. How many moles are given? How much weight it is given? 7. What is its molar mass for nitrogen? 14. Okay, and then next, other ways you can take given weight is 7 grams, the given number of moles is weight for nitrogen, no? So that will be how much? 28. Okay, but we require number of nitrogen atoms 7 by 28 into its atomicity is 2. Okay, so this will be 4 times and this will be 2 times. So we got number of moles of nitrogen is 1/2, therefore 1/2 Na. So our second option is having equal number of atoms as those are in magnesium, 12 grams of magnesium. So option 2. Similarly you can try with this option. So given number of moles of oxygen will be, given weight is 32, its molar mass also 32, will get 1 mole of O2 molecule we are getting. We require oxygen atoms only, so 1 into its atomicity is 2, so we will get 2 moles. This is not the one, so only option B. Okay, so which is the perfect answer here? Option B will be perfect suitable answer for this particular question. Hope this is also clear, right? Yes. And now one more thing, till now you have got two ways of calculation, using weight, using number of particles, and we have third way of calculation of this number of moles, that is looking at the temperature, pressure. See, there is a condition called STP, it means standard temperature and pressure. Here we are taking temperature as 273 Kelvin or 0 degrees, I can say 0 degrees, or pressure will be here considered as 1 atm pressure. Okay, so at this condition, at this specific temperature and pressure, 1 mole of any gas, if I take 1 mole of any gas, 1 mole of a gas occupies a volume of 22.4 liter. How much volume it will occupies? 1 mole of a gas occupies 22.4 liters at this STP condition. This is fixed at this particular temperature and pressure only. If this pressure or temperature changes, the volume occupied by that gas also changes. For example, I am giving you 1 mole of methane gas. How much volume it will occupies? Here you can consider as 22.4 liters of methane gas is present. Or if I am giving you 11.2 liter of O2 gas at STP, if I am saying, what does it mean? If it is 22.4 liter, you are saying it as 1 mole. Here I given 11.2 liters only na, so half of that means it must be half mole of that gas. Which gas? O2 gas. Half mole of O2 gas. At what condition? At STP condition. This is what you need to remember here. So using this also we can able to find number of moles. Number of moles of a gas at STP is equals to volume of that gas at STP by 22.4 liter. So this gives us number of moles of that gas at this STP condition. Okay, right. If you want, we'll check few questions. See, I am giving you 5.6 liter of methane gas at STP has x grams of weight, then find the value of x. What is the value of x? See, they given volume and they are asking what is the weight of that particular gas they are asking. Simple, first find number of moles of that gas, through that you can find weight of that particular gas. So first always find number of moles. How can we find number of moles? Given volume at STP is 5.6 liters and volume occupied by any gas which is having 1 mole will be 22.4 liter. So using these we can get number of moles as 1/4 mole. Okay, after getting number of moles we have one more formula, weight of that substance by its molar mass. Okay, number of moles how much we got here? 1/4. And what is the molar mass of that gas? Which gas it is? Methane. Molar mass will be 16. So you can find weight from this, that is 16/4 means 4 grams of methane. Weight of methane here it is nothing but 4 grams. So what do we mean by this? 5.6 liters of methane can be written as 1/4 moles or just 4 grams of methane. So these are the different ways of expressing the quantity of substance in liters at STP or in number of moles at STP or weight of that substance at STP. Hope this is also clear, right? Right. Will you try this question? This one question I just wanted to get answer from your side. Number of atoms present in 44.8 liters of CO2 gas at STP. Try this question, everyone. I will give 2 minutes. You can express your answer in the chat box. No issues, even it is wrong also. I am going to explain that. Okay, so just tell me your answer in the chat box. Yeah, anyone got the answer for this? Yes, tell me if it is right. Look at here, number of atoms present in 4.4 liter of CO2 gas at STP. See, 4.4 liter of gas at STP means how many moles of CO2 it is? Given volume is 44.8 liters, and we know volume of that gas at STP will be 1 mole of that gas will be 22.4 liters. It means it is 2 moles of CO2 gas. 2 moles we got right now. So we know in one CO2 particle we have 3 atoms, 1 carbon atom and 2 oxygen atoms. So total 3 atoms are there right now. So how many moles we got? 2 moles now. So 2 moles of CO2 means 2 into each mole Avogadro number of particles multiplied with 1 molecule contain 3 atoms, that is what atomicity. So 6 into Avogadro number. This many number of atoms present in 44.8 liter of CO2. So this could be your answer. Hope it is clear. If everything goes clearly without having any confusions, just click on the like button first. Okay, and you can share with your friends. Every day we will be live here, so you can join with us. You can make your preparation very effectively. Okay, and you can write the topics that you are really expecting from our side. Okay, anyways we will be going with our schedule that we are sharing 3 days or at least one week before in this NEET World channel itself. Just follow those classes. Okay, follow this schedule, or if you want any specific topic you can mention in the chat box. We will definitely look into it. Okay, and if you wanted to get the free lecture notes and all, just join our Telegram group that will be given in our description box. Just below this video there will be the details of our Telegram channel and everything. You can join through that. Okay, right. Look at this, the total number of protons in 10 grams of calcium carbonate. They have given 10 grams of calcium carbonate. So 10 grams of calcium carbonate, what is a calcium carbonate formula? CaCO3. Okay, so CaCO3 means total number of protons they are asking. What is the atomic number of calcium? It is 20. It means 20 protons are there. And what about carbon here? 6. Atomic number is 6 means 6 protons will be there. And there are 3 oxygen, each oxygen atomic number is 8, so 3 into 8. Okay, so 26 plus 20, 3 4s are 3 8s are 24. Okay, so therefore it will be 50. How many protons are there in 1 mole of CaCO3? We have 50 moles of protons. Okay, they have given 10 grams. So 1 mole of CaCO3, what is its molar mass? Calculate. Calcium atomic number is 20, so molar mass will be 40 plus carbon will be 12 plus 3 into oxygen 16. So 100 gram per mole is a molar mass of this calcium carbonate. Okay, so they are saying in 100 grams, as per this data, 100 grams we have 50 Na protons are there. 50 Na protons are there. Okay, and they given 10 grams only, just divide it by 10, it means here also just divide it by 10, so 5 into Na, that's it. So 5 into 6.022 into 10 power 23 will be our answer. Okay, so that is nothing but 30 into 10 power 23 we can write, or simply 3 into 10 power 24 we can write. So we have option number 3 as 3 into 10 power 24, that will be our answer. Okay, this is also clear now, right? Let's move forward with few more things. Can you answer this? Calculate number of moles of carbon atoms in 90 grams of glucose. How many carbon atoms are there in 90 grams of glucose? So first you need to know the glucose formula, C6H12O6. Okay, so its molar mass if you calculate, you will get 180. Okay, 6 into 12 plus 12 into 1 for hydrogen plus 6 into 16 for each oxygen. Therefore, sum will be 180. So given weight is 90, by its molar mass is 180, so that we will get 1 by 2 moles. So 1 by 2 mole glucose contains 1 by 2 into Na number of glucose molecules. So in one mole of glucose we have C6H12. They are asking carbon atoms only now. So C6H12O6 means in one glucose we have 6 carbon atoms. Okay, they have given half mole of glucose means 1 by 2, half into 6 carbons, 6 moles of carbon. So that will be 3 Na number of carbon atoms are there, or specifically if you want to mention 3 into 6.022 into 10 power 23 carbon atoms are there. So 18 into 10 power 23 will be your answer for this particular question. Okay, hope this is clear, and I just wanted to get the data that number of hydrogen atoms in the same question and number of oxygen atoms, what will be the answers for this. Okay, and total number of atoms like carbon, hydrogen and oxygen atoms from the given data. Tell me these 3 questions in the chat box. Okay, so whenever you are watching this video, just try to answer these 3 answers. Right. Next, will you try this question? Okay, let me explain this concept, then after you can solve. See, I have shown you one question at the beginning of the session. Without explaining anything, I have shown you one question that you can able to solve very easily. Na? So similar way we have one more question from NEET exam also. Just look at here. Preparation of ammonia through Haber's process. For that, how many moles of hydrogen molecules are required to produce 20 moles of ammonia? So 20 moles of ammonia means, first write ammonia NH3. So this comes from where? N2 plus H2. Try to balance this equation, N2 plus H2. 2 nitrogen atoms are there this side, so 2 NH3, and here 3 to just 6, here only 2 are there, so 3 H2. So after balancing these, what they are saying, 20 moles of ammonia through Haber process. So 2 becomes 20 means multiply with 10. Okay, so 20 NH3 done this side. And this side also, if you are multiplying 10 to the reactants product side, same number you multiply reactant side also. It becomes 10 N2 plus 30 H2, that's it. So what will be the answer? The number of moles of hydrogen molecules required here are 30 moles. So option 3 will be answer here. And how many moles of nitrogen is required? 10 moles here, first option, if they ask for nitrogen gas, right? Okay, next. Okay, so in similar way, I will be asking you few more questions. Tell me, So for combustion of methane, it will give CO2 plus H2O, right? So now, how many moles of water produced by combustion of 4 moles of methane? 4 moles of methane upon combustion produces how many moles of water? This will be the question I am asking. Based on the understanding in the previous question, you can able to solve this question. Okay, so please try to answer this in the chat box. Okay, right. Next question we have. See, I will tell you about this percentage composition today to some extent, and will continue the remaining in the next session. Okay, so mass percentage we have, by mole percentage we have. Okay, so mass percentage means, for example, there is A, B, C, D like this, four separate compounds are there in a mixture. So I have taken this A, B, C individual things and I mixed them, having some quantity of A, some quantity of B, C, D like that. Now if I ask for percentage of A, what could be your answer? The weight of A by total weight of that substance. Total weight of that substance into 100. So this will be giving us percentage composition of A in terms of its weight right now. So for example, I am giving you 16 grams of methane, I am giving you. 16 grams of methane I am giving you. So what will be the percentage of carbon in this? It means percentage of carbon will be taken as weight of carbon by total weight into 100. What is the weight of carbon in 16 grams of methane as per its molecular formula? So for in order to construct methane of 16 grams, we require 12 grams of carbon now, right? 12 by what is the total weight? Carbon weight is 12, 4 hydrogens, each hydrogen atomic weight is 1. So 12 plus 4, 16. So 12 by 16 into 100. So this will be giving us percentage of carbon in this methane. Similarly, percentage of hydrogen, if I ask, 4 by 16 into 100, that's it. So this will be 3 by 4. So we will get 75% of carbon by weight and 25% of hydrogen by weight in this 16 grams of methane. This is how you need to calculate percentage of composition by weight. And when it comes to percentage of composition by mole, similar question I am taking. 1 mole methane I am saying. In order to make 1 mole of methane, we required, in order to make this 1 mole of methane, we require 1 mole carbon and 4 moles hydrogens right now. So it means percentage composition of carbon by mole, if they ask number of moles of carbon by total moles into 100. So how many moles of carbon is there here in 1 mole of methane? 1 mole now. 1 mole of carbon is there in each mole of methane, and total number of moles, 1 mole carbon plus 4 mole hydrogen, that will be 5 into 100. So this will be 20% of carbon by mole when it comes to percentage by mole. When it comes to by weight, it will be 75%. Now if I ask percentage by mole of hydrogen, if I ask, what will be your answer here? How many hydrogens are there? 4. So 4 by total are 5 into 100. So this will be 80%. I hope you got. There will be different answers mostly when we compare the weight percentage with the mole percentage. It depends on quantities that we have taken in the weight and we have taken in the moles. Okay, hope everything is clear, and if you have any confusions or concerns regarding this particular topics, whatever we have discussed, you just write in the chat box. Tomorrow again we'll meet at the same time with numericals, theory, again PYQs. In this way we'll make ourselves better in our preparation. Okay, hope you like the content and you will join these sessions regularly, and if you want to join our personal batches, you can just reach us using the mobile numbers provided in the description box. Okay, so thanks for watching. Stay connected with this NEET World channel. Thank you.